We're going to explore syntax diagrams in context-free languages. Now, syntax diagrams, they're another way of expressing the production rules that we have, for example, within Backus-Naur form. And the symbols for the syntax diagrams are given here, where we have terminal symbols that are represented by ovals. We have non-terminal symbols that are represented as rectangles, and we have recursion where we have the arrow going back to the start, going back to the beginning of the non-terminal symbol, so we're able to repeat that non-terminal symbol in a recursive manner. Let's have a look at an example of some Backus-Naur form production rules. So we're going to do this really simple example where we have a set of binary numbers that we can express either as a binary number or as an expression where we're adding two binary numbers together with an arbitrary number of bits. So examples of valid expressions are given here. What we're going to do is we're going to take this set of production rules and we're going to show the equivalent of what it looks like as syntax diagrams. So for each of the production rules, we're going to go through, show the equivalent syntax diagram, and here is the first one. This is the production rule for bit, where we have 0 and 1 as our terminal symbols and bit is our non-terminal symbol. So we get the choice. You can see there that we can take an alternative path for either 0 or 1. You can see that through the syntax diagrams where 0 and 1 are shown in parallel there, so we can do one or the other. This shows the binary production rule, and the syntax diagram shows that it's recursive, so we can take a bit and we can repeat that bit and we can keep adding a bit to our binary number, so we can have it to be of any arbitrary length that we wish it to be by repeating it however many times that we need to. And then we have a slightly more complex one to define the expression, where we have two alternative paths here. So we have the top path, the binary path, and in parallel we have the binary plus binary. So the top one here will allow us to generate just a single binary number. The bottom will allow us to generate a expression that allows us to add two binary numbers together. And you can see that we have binary, we have plus here, which is a terminal symbol. Binary, of course, is a non-terminal symbol. And we have two on the bottom path here. We have two binary symbols here that we are adding together using our terminal symbol here. So we add those two binaries together and we get our valid expression. Let's have a look at a second example where we have a set of production rules that allow us to represent a signed number. In this case, it can be a whole number, it can be a real number, and it can either be prepended with a plus or with a minus to indicate whether it's positive or a negative number. And some valid expressions here are given below. Let's have a look at the corresponding syntax diagram for each of those production rules. So we have digit here, where we have 0 through 9 are our terminal symbols, and we can have a choice of any of those digits from there. Notice they are in parallel, so we can only choose one of those digits out of those 10. Next, we have our recursive production rule here. Notice how digit, which is a non-terminal symbol, we can effectively call it as many times as we wish. We can go around and recursively add as many digits as we wish to our integer. Then we have this path here where we could just have a single integer if we took the top path, or if we want to express a real number, we can take the bottom path, which is running in parallel, and what that will do, it'll add a point, which is a terminal symbol, to another integer effectively. So we'd have an integer before the point, decimal point, and one after the decimal point to express our real number. And then finally, the signed syntax diagram is given here, and you can see it's again very parallel in its nature. We have a number if you just wish to have the number without the expression of the plus or the minus in front of it, or if you wish to take a different parallel route, you can take the alternative route where you're putting a plus, which is a terminal symbol, or a minus, which is also a terminal symbol, in front of the number itself.